The next big thing, is it truly revolutionary, poised to reshape the digital landscape as we know it? Or will it fade into obscurity, another fleeting trend in the ever-evolving world of technology? Or just a really small thing? A niche application with limited real-world impact, destined to be a footnote in the history of computing? Ever get that twitch when a new JavaScript framework drops and you think, great, another thing to learn? Another syntax to memorize, another set of best practices to internalize. You just mastered React hooks, server-side rendering, and even made peace with CSS. You finally found your groove, your workflow is humming, and you're shipping features like a pro. But what if the next big shift isn't just a new framework? What if the very foundation of computing, the ones and zeros, gets a magical upgrade? A fundamental change that could unlock unprecedented computational power. This isn't science fiction, it's happening now, in labs and on cloud platforms worldwide. It's called quantum computing, and its impact on your career as a web developer could be very real. You might think, I build websites. What does subatomic physics have to do with me? But remember when the internet was just a fad? A passing trend that wouldn't amount to much? We're going to break down quantum computing with ideas and analogies that click for developers. We'll translate the complex jargon into concepts you can actually use. Think of this as the ultimate hello world for the next era of computing. The goal isn't to turn you into a quantum physicist, but to give you a head start and show you that quantum is just another tool, albeit a weird, powerful one. A tool that might just revolutionize the way we build and interact with the web. So grab a coffee, open a new mental tab, and let's dive into the wonderfully weird world of quantum computing. Get ready to expand your horizons and explore the possibilities that lie ahead. So, what is this quantum voodoo anyway? It sounds like something out of science fiction, doesn't it? But trust me, it's very real and it's poised to revolutionize the world as we know it. Quantum computing isn't just a faster version of your laptop. It's a completely different paradigm. That's like saying a rocket ship is just a faster car. A gross understatement of the capabilities involved. They operate on totally different principles, leveraging the bizarre laws of quantum mechanics. Classical computers use bits, the fundamental unit of information. On or off, 1 or 0. A bit can only be in one of these two states at any given time. Simple, reliable, the bedrock of digital life. It's how all our current technology functions. Quantum computers use qubits, quantum bits. Imagine a dimmer switch that can be on, off, or anywhere in between, all at once. This in-between state is what gives quantum computers their edge. This is superposition, the core idea behind quantum's power. A qubit can exist in multiple states simultaneously. Picture trying to crack a lock. A classical computer tries every combo one by one. A slow and methodical process. A quantum computer explores all combos at once thanks to superposition. It's like reading every page of a book simultaneously and instantly understanding the plot. The possibilities are truly mind-boggling. Quantum isn't here to replace your MacBook for emails or CSS. It's here to solve problems that stump even supercomputers. Problems that are currently intractable. Optimization, drug discovery, and yes, even things that affect web developers, are all in quantum's sights. It's a game changer across numerous fields. Classical computing is linear and predictable, it follows a set path. Quantum is parallel and interconnected. It explores multiple paths simultaneously. It's a new way of processing information, a new frontier in computation, mirroring the universe's weirdest rules. It's harnessing the power of the quantum realm. The quantum wave is coming for the web. It's not a matter of if, but when. Let's see how. Let's dive into the specifics and explore the potential impact. Let's dive into the fascinating world of quantum computing and meet the qubit, the indecisive bit. It's a fundamental building block that sets quantum computers apart from their classical counterparts. If a classical bit is your reliable yes-no friend, always giving you a definitive answer, a qubit is your kinda yes, kinda no, maybe both friend. It exists in a state of uncertainty, a probabilistic blend of possibilities. This is superposition. A qubit can be 0, 1, or both at once, existing in this mixed state until you measure it and force it to commit to a single value. Think of a JavaScript promise. Before it resolves, it's pending, potential for both outcomes, either fulfillment or rejection. It's in a state of flux, waiting to be determined. Qubits exist in a cloud of probabilities, a weighted mix of 0 and 1, with each possibility having a certain likelihood of being observed. Two classical bits equal sign one of 4 combos at a time. They can only represent one combination at any given moment. Two qubits equal sign all 4 combos at once. This is where the power of quantum computing starts to become apparent. 300 qubits? More combos than atoms in the universe. The number of possible states grows exponentially with each added qubit. That's exponential scaling. This allows quantum computers to tackle problems that are impossible for classical computers. But quantum states are fragile. The slightest disturbance, heat, magnetism, can collapse a qubit superposition, causing it to lose its quantum properties and behave like a classical bit. It's like a promise erroring out before it resolves, leading to an unhandled rejection and a failed operation. That's why quantum computers are kept at near absolute zero and shielded from the world, isolated from any external interference that could disrupt their delicate quantum state. They're the divas of computing, delicate, high maintenance, but incredibly powerful. Their potential is immense, but realizing it requires extreme care and precision. Keeping them stable long enough to compute is a huge engineering challenge, pushing the boundaries of what's technologically possible. But that's what unlocks their magic, enabling them to solve problems that are currently beyond our reach. Superposition. It's not just for superheroes. Imagine a quantum slider input. Before submitting, it's 70% A, 30% B. When you hit submit, it snaps to 1. Probabilities become reality. That's superposition, not just uncertainty, but true probabilistic existence until measured. Quantum algorithms manipulate these probabilities, nudging them with quantum gates, like logic gates, but for probabilities. The goal? Amplify the right answer's probability, cancel out the wrong ones. So, quantum computers don't just try all possibilities at once, they explore a landscape of probabilities. Programming quantum is like choreographing a dance of probabilities, not writing if-else statements. It's about setting up interference patterns so the right answer stands out. This is a whole new way of thinking about computation, moving from certainty to controlled probability. The art is in guiding the system toward the correct answer. It's less about brute force, more about elegant probability manipulation. That's the quantum edge, and it's coming to your toolbox. If you thought superposition was weird, buckle up for entanglement. Entanglement links two or more qubits so they act as one system, no matter the distance. Measure one, and you instantly know the state of the other, even across the galaxy. Imagine two web apps, one in New York, one in Tokyo. Change the state in one and the other updates instantly. No API, no network. That's entanglement instant spooky linkage. It's not just a curiosity, it's a resource. Entanglement weaves qubits into powerful, interconnected systems, enabling complex algorithms and ultra-secure communication. For web developers, this means new cryptographic protocols. If a hacker tries to eavesdrop, the act of measuring breaks the entanglement and triggers an alarm. Think unhackable communication, quantum security for the web. The future of secure data is entangled. Classical computers are the workhorses, running your IDE, compiling code, serving websites. Quantum computers are the specialists, solving problems classical machines can't touch. The future is hybrid quantum and classical working together. Think CPU and GPU. CPU handles general tasks, GPU crushes parallel calculations. You don't run your OS on a GPU, but you offload graphics for speed. Soon your classical code will offload hard problems like optimization or encryption to a quantum processing unit via a cloud API. As a web developer, you'll identify which parts of your app need quantum speedups and use APIs to connect to quantum hardware. You'll still write JavaScript or Python, but now you'll have a new async call quantum. It's about knowing which tool to use for which job. Quantum won't replace your stack, it'll supercharge it. Get ready to bridge two worlds. How does quantum actually impact web development? The biggest, most immediate effect: security. Today's encryption, RSA, relies on factoring large numbers, a hard problem for classical computers, but trivial for quantum ones running Shor's algorithm. In a quantum future, current encryption could be broken. That's huge. The race is on for quantum-resistant cryptography. You'll need to update servers, libraries, and protocols, just like the move from HTTP to HTTPS. Beyond security, quantum will revolutionize optimization and AI. Imagine optimizing a massive shipping network. Quantum finds the best route in seconds, saving millions. You'll integrate quantum APIs for logistics, AI, and more. Quantum computers are also great at simulating quantum systems. Think drug discovery or material science. You might build web interfaces for scientists, visualizing molecules calculated in real time by quantum backends. The web will be the main interface for quantum power. As a developer, you'll make this power accessible. The quantum revolution will run through your code. This might sound far off, but you can start writing quantum code today. No million-dollar lab required. IBM, Google, and Microsoft offer cloud platforms and open-source SDKs for quantum programming. IBM's Qiskit, Python-based, lets you build quantum circuits and run them on real hardware or simulators. The IBM Quantum Experience even has a drag-and-drop web interface. Microsoft's Azure Quantum and Q hash language integrate with familiar tools. Google's Circ is another Python-based framework. These platforms are making quantum development accessible. No PhD required. Start with simulators, work through Hello World tutorials, and experiment with entanglement. You'll build intuition for quantum concepts by playing with real tools. The barrier to entry is low, just bring curiosity. Take your first steps into the quantum world now. We've journeyed from bits and bytes to qubits and entanglement. It's a lot, like staring at a massive unfamiliar code base. But you don't need to understand it all at once, just find an entry point. The web is defined by change. We're lifelong learners, always adapting. Quantum is the next big wave, don't ignore it. Your mission: start playing. You don't need to be an expert, just be curious. Try IBM Quantum Experience, watch a Qiskit tutorial, read about post-quantum cryptography. Plant the seed. You don't need to build a quantum computer, just be able to talk about what it can do. Be the teammate who says, hey, maybe there's a quantum approach to this problem. The web community has always bridged complex tech and human experience. Quantum will be no different. It needs people like you. The quantum future is coming, and it needs a web. You can help build it.